In this segment, we're going to run a Kruskal Wallis in SPSS. We're going to use the same data that we used for the ANOVA, our nursing home coronavirus data. Remember, it wasn't normally distributed, so we're going to try Kruskal Wallis to see if we can get any better test results. Basically, Kruskal Wallis is a non-parametric alternative to ANOVA. You don't need normally distributed data. Once again, this methodology uses ranks and takes a look at distributions, so we report medians rather than means. The test statistic for it is an H statistic. So that's the background. There are 4 pretty simple assumptions. We need an independent grouping variable with 3 or more groups again. The variables can be ordinal, ratio, or interval, so almost anything. And we need independent observations and similar shapes for group distributions, and SPSS will test that for us. We have the same data set and the same hypothesis, so we're going to go to SPSS, click Analyze Non-Parametric Tests, Independent Samples, go to the Fields tab, and do these 2 operations. So let's go do it. Here's our data set. Analyze non-parametric tests, independent samples. First we go to the fields, and we're going to put in COCC, cases per occupied bed, and the groups here are going to be code. We'll go over to settings. And if this was checked, we're going to click Customize Tests, Kruskal Wallis One-Way ANOVA, all pairwise. And that's all we need to do. So here we go, Run. And here are results. Up top here is the null hypothesis, which it did for us. The distribution is the same across categories. Independent samples Kruskal Wallis test. It is significant, so we reject the null hypothesis. SPSS did the whole thing for us. If you want to check the test statistic, it's 21.953 with 3 degrees of freedom, and once again, it's significant. Remember I talked about similar distributions. Here, the program with these little cylinders is checking for similar distributions. And basically, these look fairly similar, although this elongation for Dauphin County may suggest that the distribution for Dauphin County may be different. Scrolling down, here are our pairwise comparisons, and we get exactly the same results as we got with the ANOVA. Pairs 1 and 3 are significant. Pairs 1 and 2 are not. Pairs 1 and 4 are significant. And basically Allegheny County is less than Philadelphia County here, and here this is less than Montgomery County. And as you can see here, there are no more other significant pairs. This gives you some average ranks, and here's distributions. And we're not going to do much with those. So, simple, straightforward, not difficult to interpret. We conclude that we rejected the null hypothesis that the mean numbers of cases per occupied bed were the same for Allegheny, Dauphin, Philadelphia counties, and accept the alternative hypothesis.